Hello everyone and welcome to 16th topic of digital image processing of remote sensing data course. In this particular lecture we are going to discuss the principles of image interpretations, and so far several times I have mentioned in the during the course of this course basically that ultimate aim for image interpretation, all processing which we are going for better image interpretation, so then we can do the reliable interpretations and can make inferences out of these images. Especially I am talking about satellite based remote sensing images. So there are different ways of doing interpretations, but there are some fundamental, we say, interpretation keys which are there. So we will discuss each keys one by one, and then we'll see some examples as well. So the different principles of image interpretation, this is mainly about, I am talking about visual interpretation. Classification techniques which we have just discussed in the previous lecture is for the computer based sort of interpretations. But here I am talking about visual interpretations, which is many times it is much more reliable, and when we didn't have digital image processing based or computer based classification techniques, we used to do on visual interpretation. Visual interpretation is still very useful, very reliable, and ultimately even on the computer based classification techniques one has to perform visual interpretations. So visual interpretation of satellite images is important in remote sensing as well as in GIS for different applications. And this is the skill. More you interpret images, different images of different areas, more you learn, and later on you apply that experience to some new images which are presented before you. So there are different types of data which we use, on which we have to do image interpretations. Earlier we used to have aerial photographs. Sometimes they are in black and white or false color composite. Same with the satellite images. You may have a single band image in grayscales, or you may have a color composite or false color composite in 3 colors, or maybe a composite of principal components composite. So that is also false color composite, but interpretation about, especially about colors, is going to be different. So visual interpretation, and most of now these images are in digital form, so we try to perform interpretations on a screen itself in digital form. So depending on correction applied and level of processing, the different remote sensing data like raw data, which may be having radiometrically and geometrically uncorrected. So if we make interpretations, then different types of errors may be introduced. But after the all kinds of processing, we can do this processing. So there are different products which are available to us, which are in digital form for raw data, maybe standard data, maybe geocoded product, precision products. Geocoded products are those products in which geographic coordinates have been added. That means they are georeferenced images. And standard data products are where radiometric and geometric corrections have been performed. And precision product are those which are radiometrically corrected, geometrically corrected, and having your geographic coordinates and using use of GCPs, ground control points, of some libraries, and create, like our National Remote Sensing Agency, they having, as per my understanding, they are having 30,000 ground control points collected from different parts of the country using a differential GPS techniques. So their ground control points are very precise. They look the corresponding ground control point of that area within that a single image and do the georeferencing, and then it is called the precision product. So different kinds of products are available on which but the interpretation, keys interpretation, and the way it is done, it is going to be almost same whether it's a uncorrected image or corrected image. But you have to remember that which kind of product on which you are doing this thing. If you are doing on false color composite, then one has to remember the color, that healthy vegetation will appear in red color. But if it is a different color composite, maybe a true color composite, then vegetation will appear in green color. So that one has to remember. That is why this slide is being shown. You might be having one more type of product, which is a merged product. So image merging, image fusion, that we will see. But this is how these products are. When you are having in one image, you are having high spatial resolution. In another false color composite, you are having color information, and you are looking to combine or extract the best out of these two input images and put in one product. So that we call the merge product or pen-sharp product. And this is one example of Delhi, where list 3 pen data is there, 5.8 meter spatial resolution, and the corresponding image is list 3, and list 3 data. This is the pen data of 5.8 meter resolution. The list 3 is 23.5 meter resolution. So here on the right side, the resolution relatively is coarser, but you are having color images. Whereas pen image is having a higher spatial resolution, but is in black and white. And you can see that interpretations on both these images is going to be different, because color images are more easier for interpretations than black and white images. But we can create a product also which is merged one, fused one, or pen-sharp one, and on which we can do the image interpretation. So different products are available, and therefore the strategies for interpretations have to be little different on that. Now visual image interpretations, that is process of identifying what we see on the images and communicate the information obtained from these images to others for evaluating its significance. And this includes relative location and extent, because each object is located in a specified location generally, like beaches are located along the sea or in along a large lake. Only just all of a sudden on land you may not have beach. So the location is very relevant, as well as the extent, how they are extending in a linear fashion, round fashion, then they will allow us to do the interpretation. All these things, the logic about each ground features is there always. So use of data products like satellite single band image, false color composite, performing image interpretations to extract thematic information for subsequent input to GIS or creating some new products. So what are the interpretation keys, or these are the criteria basically. So criteria for identification of an object with interpretation elements or keys are that you are the location example I have just given, the size of an object, a feature, how big, how small. That will also give you, once you understand the spatial resolution, then you may decide that okay, this object is there, but this might be this object because the size matches with your experience of on the ground itself. So size is important, shape of the object is important, shadow, because most of the images which we interpret belongs to the daytime images. And generally with sun synchronous satellites or remote sensing satellite, the images are acquired generally in the morning hours. And then there will be a shadow. Generally in such images, there will be a shadow in the northwest direction. So shadow can also be exploited to understand a ground feature or make better interpretation. Tone, and what is whether it's a dark tone, light tone, depending on the type of image. If you are having black and white image, then tone plays very important role. But if you are having color image, then the colors plays very important role. Then you are having texture, what is whether it's a speckle texture or some other textures are there, which you will decide. Say small agricultural land will have a different texture as compared to a deciduous forest. A conifer forest and deciduous forest will have different texture. So that is what texture is. Then pattern is there, how things are there. If there is a fluvial river in a plain area, then you will see a meandering kind of pattern, or might be in some other features will have a different pattern. So pattern also plays while doing the image interpretations. Heights and depth. Height has indirectly has come in the shadow, but depth can also play very important role. Site, where it is located, situation and association. As I said, beaches are associated with large water bodies, either seas or big lakes. So that is the association. A beach cannot be on simple ground. So that one has to remember, and based on all these interpretation keys, the one individual makes the visual interpretation. So we will see one by one all these. So location, that is, there are two primary methods to obtain precise location in the form of coordinates. So the survey in the field using traditional survey techniques of global positioning system instruments, and there be the collect remote sensing data of object, rectify the image, rectify means here the georeferencing, and then extract the desired coordinate information. So because we need the location information, so that has to come from some way, either directly from field or from a georeferenced image. And the most users, most remote sensing scientist users use relatively inexpensive GPS instruments in the field to obtain desired location of object. But I gave the example like NRSS, they have collected very precise GCPs, and that is why when the product you created or the georeferencing is done based on the precise GCPs. Why it is precise? Because they have used differential GPS techniques in which your precision improves significantly of your location, and therefore the georeferencing of really you get of high order. Now size also play, size of an object on the ground. That will give you the idea what object it is. So the size of an object is one of the most distinguishing characteristics and one of more important elements of image interpretation. And most commonly the length, width, the perimeter are measured. To be able to do this successfully, it is necessary to know the scale of photo. At what scale the image is being displayed, because we are talking now interpretations on a screen itself. So when you zoom in, zoom out, the scale changes. So one has to remember at what scale you are seeing. For example, let me give you the example. Like if I know that it's a railway track, so I am having some idea about the size. Broad gauge railway will have this much of width, maybe not along the rails, but total area involved maybe 2 meter or 3 meter. So I am having now the width of the railway track, the idea about the width of railway track. And if I find this is in a linear fashion and bends are not very sharp, then I can identify very easily that it's a railway track. But if I find sharp bends, some crossings and very wide compared to railway track, no single tracks or rails are available, then I may say these may be the road network and so on. So the size is important, and size would be decided based on the scale on which we are making interpretations. On digital, one has to be little careful when displaying zooming and zoom out, because scale will change. And most commonly measured parameters, as mentioned earlier also, length, width, perimeter, area, and occasionally volume. Volume, little difficult to measure, you require a third dimensional information, but with the availability of digital elevation model, this too has now become possible to measure. Now the third in the interpretation elements or keys is the shape. Shape plays very important role. Shape of an object is described as the geometric form represented on an image. Regular shapes are signs of man-made objects, like houses, buildings. So these are regular shapes. They may be rectangular or in square in shape. Generally, this is how we see. And large colonies are having there, or multi-story buildings. So they are having a fixed shape kind of thing. So regular shapes are signs of man-made objects, and irregular shapes with no distinct geometrical pattern are signs of natural objects. So we can identify on satellite images that which one are the regular shapes. or then we can identify that we know that these might be the man-made shape, man-made structures and the built-up land. Like we can classify or declare that this is a built-up land, or a city, or a town, and so on and so forth. Whereas irregular shapes, like a river will have irregular shape with no distinct geometrical pattern or sign of a natural environment. Earlier also I mentioned the role of shadow. In the sun synchronous satellites, the data is acquired roughly between 9:30 to 10:30. At that time, sun is in the southeast quadrant, and therefore the shadow would be in the northwest quadrant and northwest quadrant of the objects which are having some height. If it is completely flat, like a river will never have a shadow, but a tree will have a shadow, a building will have a shadow, and especially I am talking about mountainous regions where there are ridges and valleys. So ridges will have shadow. So half of the valley might be covered under the shadow during that time when data is being acquired. So based on the shadow, lot of interpretations are made. Generally, remote sensing data from polar orbiting satellites collected between 9:30 to 10:30, as I have just mentioned, to avoid extended shadows in the image. And this is because shadows can obscure other objects that could otherwise be identified. So sometimes the other objects goes in the shadow, that means they become darker, and therefore their identification, interpretation becomes difficult. On the other hand, the shadow cast by an object may be key to identify the another object. Sometimes it becomes advantageous as well. Example is this Washington Monument example is here. On the left side, which you see the photograph taken from the ground, and this is taken by the satellite. So on the ground, when you are taking photograph, you are not seeing the shadow. The shadow will be seen once you are seeing from the top or on some oblique photograph. Here the image, and this is the shadow. And as I was saying that the image, the sun must have been here, and if this is the north, then this is the shadow. And the shadow will give you the idea about the width of an object as well. So take for example this Washington Monument in Washington DC. While viewing this from the above, it can be difficult to discern the shape of the monuments. Whereas on the ground, this is how. But with a shadow cast, this process becomes much easier. It is good practice to orient the photos so that the shadows are falling towards the interpreter. That is also because they in a highly rugged terrain, if you do not orient your image properly, then you are bound to have a false topographic perception. And the result of this would be that the valleys will appear as ridges and ridges as valleys. So while doing the interpretation, take care about this, because the shadow is basically, so this pseudoscopic illusion, which we have given name false topographic perception phenomena, can be produced if the shadow is oriented away from the observer. And this happens when low points appear high and high points appear low. Means valleys will appear as ridges and ridges will appear. Now shadow gives height information about hill, towers or tall buildings. So if we know the position of the sun, that means the illumination source, angle and azimuth, especially the angle, we can estimate the height of a tower using the shadow, even in one single image. So this is a simple trigonometric solution is there. As example is shown, that satellite is taking data from here. This is the height and this thing. So if this is the tower, then it is having shadow up to this one. So this simple trigonometric solution can be there, and the example is given about the world highest building, which is Burj Khalifa. Example is here. So shadow gives height information about hill, towers, tall buildings and so on and so forth. This is what I was mentioning about false topographic perception phenomena, a pseudoscopic vision. That means I am having a single image, but still I am seeing depth perception. So this is also, we can put them as pseudoscopic. But why false topographic perception phenomena? Now shadow is playing major role here, because as I have mentioned that when this image was acquired, at that time the sun was in the southeast quadrant. And when I keep north upward, then I am seeing the snow covered peak in depression, and we know it is not correct. The peak has to be really a peak, that it should appear not in depression but as a mountain. So because of shadow, this inversion is there, or false perception is there. But if I rotate this whole image by 180 degree, that means I am forcing sun, instead of in southeast quadrant, I am forcing sun to go in the northwest quadrant by rotating by 180 degree like this. Now I get the correct perception. So there is no change, no manipulation, no image processing techniques here employed, just physically rotated the image by 180 degree, or here digitally rotated image. And now we are seeing incorrect perception. The problem here, that if the illumination source and interpreter, that is viewer, if they are in the same hemisphere, in this case southern hemisphere, so your sun is also in the southeast quadrant, the observer is always assume himself in the southern hemisphere, north is upward. When this arrangement is there, satellite is taking photograph from top or image from top, you are bound to see a false topographic perception phenomena. But when you rotate this image, you are virtually forcing the sun to go opposite to viewer or interpreter. And when these are two different hemisphere, means the illumination source and the interpreter, then the false topographic perception phenomena is gone, and therefore you see things in correct perception. This is there is a separate discussion on and this, but in this one, this is what I wanted to discuss here. So shadows plays very important role, especially of hilly regions or where you are having large shadows due to buildings or mountains and other things. Now another important keys or elements of image interpretation after shadow are tone and colors. Tone basically for black and white images, that band of EM spectrum recorded by remote sensing system may be displayed in shades of gray ranging from black to white in gray scale. So two extremes, black and white, two extremes, and in between you are having gray image. So this we say tone. Tone is a continuous gray scale varying from white to black. For digitally the values are changing one after another. For us, we can only distinguish 16 shades of gray maximum. Our eyes are only sensitive, but computers can generate even 256 shades of grays, two extreme members, black and white. So that continuous gray scale varying from white to black, and in between you are having gray. So when you are having a lighter shades of gray, then you call as light tone. Otherwise, if it is darker, you call darker. So it refers to relative brightness or color of object in an image. So vegetation, water and bare soil reflect different proportions of energy in different bands, blue, green, red and infrared portions. For example, in infrared band, infrared part or portion of electromagnetic spectrum, vegetation reflection is always very high, healthy vegetation reflection. Whereas water body will appear completely dark with dark tone, because in that part of EM spectrum, the infrared energy is completely absorbed by water bodies, and that then reflect signals do not reach to the satellite, and hence it records very dark tone. Whereas in infrared band, the vegetation is recorded in a light tone, healthy vegetation I am talking. Similarly, for different objects, they will record differently, and depending on their shade, we say light tone and dark tone. So an interpreter can document the amount of energy reflected from each object at a specific wavelength to create a spectral signature. And these signature or the understanding about different natural objects will allow us to make better interpretation. So it's a training. First image is given to you. For image interpretation, you would find very difficult to interpret initially. But once you start interpreting and realizing and then comparing with ground features, slowly you becomes you can do much reliable interpretations and at a very high speed, because it's a self-learning. Now in this one, these signatures can help to understand why certain objects appear as they do on black and white or color imageries. Like in false color composite, because for infrared channel you have assigned red color, and vegetation is reflection high in infrared channel, therefore in false color composite that will appear as red. And if vegetation is not healthy, then it will not appear red. It will have a different color, maybe little yellow and so on. So these shades, and if in black and white you are having gray shades of tone, and darker an object appear, the less light it reflects. I am talking about the mainly in the visible and infrared part. Whereas in thermal and infrared part, it is not the reflection, it is the emission which is recorded by the sensor. So the image interpretation of thermal images is completely different than reflected images. So one has to remember while doing the interpretations of different parts of EM images of different parts of EM spectrum. So color image is often preferred by humans, because as opposed to the shades of gray, humans differentiate 40, 50, but it is even, I tell you, it is in real 15, 16 maximum we can wear, whereas human can detect thousands of different colors. So color detection capability of human eyes is much more compared to black and white or gray. And color aids in the process of photo interpretation. So always color images are more soothing, more comfortable for our eyes for interpretations, because most of the time we are seeing the real world in color in normalized conditions. Now next one is the texture. Next characteristics or next element is the texture, and texture, that is the characteristics, placement and arrangement of repetition of tone or color in an image, that will give you the texture. And the visual impression of roughness or smoothness of an image region, a part of image, how it is appearing, whether it is very smooth or very rough. The next another one is the pattern, how things have been arranged in an area. So the pattern is the spatial arrangement of objects in the landscape. The objects may be arranged randomly or systematically. They can be natural or with the drainage pattern of a river or man-made. Like drainage systems are always having pattern depending on the land or lithology where they are, or topography. So by identifying those patterns, we can infer that probably the land or the lithology is something like this. Whether we can differentiate if it is hard rock terrain or alluvial. If it is hard rock terrain, which type of rocks are present? Some guess, some interpretations can be made based on just looking the drainage pattern. So this kind of patterns are very important in image interpretations. And other objects which we describe can be used, like in pattern we say random, systematic, circular, oval, linear, rectangular, curvilinear, and there are many names which can be given for pattern. Like a river in a flat area, almost flat areas, may have a pattern helical and meandering pattern. And a river in a mountainous region may have a very straight kind of, or maybe a sharp bend because of hard rocks present there. Now site, situation or association, these are all linked, keys are there. Association, the site has unique physical characteristics which might include elevation, slope, types of surfaces cover, that is grass, forest, water, bare, soil. For example, if I am seeing a cone shaped, very light toned areas, I cannot say that this is a landslide area for a flat terrain or like a area like alluvial plain, Indo-Gangetic plain. But if I see a similar this light tone kind of cone or a triangle in a hilly region, I may suspect there might be landslide. So this, because of the site where it is located, situation, my interpretations should be accordingly. So this understanding is developed after doing interpretations on some images. Site can also have socioeconomic characteristics such as value of land or closeness of water. And situation refers to how the object and the image are organized and situated in respect to each other. And this most popular power plants have materials and building associated in a fairly predictable manner. So based on the satellite images, and if we spend more time and we know from our knowledge that how a cement plant will look, because there will be a raw material, there might be some products, and how chimneys and other things are arranged, we can say that probably this is a cement plant or a fertilizer plant or maybe a sugar cane plant or sugar factory or maybe a thermal power plant. So depending on the situation, association of all surroundings, we can identify an object or interpret an object. Association refers to the fact when you find a certain activity within a photo or an image. Nowadays most of the time we are doing image interpretation, that too on the screen. You usually encounter related to associated features or activities. Site, situation and association are rarely used independent of each other when analyzing an image or interpreting an image. And an example of this would be the large shopping mall. Usually there are multiple large buildings, massive parking lots, and usually located near a major road intersections. So we say if we find this kind of arrangement, situation, a site or association of different things like road junctions, large buildings, massive parking lots, probably we can say that this might be a mall. Some examples are given here. The real examples like shape. If I see shape like this, I may say that this might be a stadium. Or if I am seeing a golf course, then I will see a different type of shapes and greens and holes and other things. The size also matters. Size depending on scale, but still in relative sense it matters. Then tone, dark tone, light tone, depending on which channel I am using. So the vegetation in visible channel will appear in dark tone, whereas vegetation in infrared channel will appear brighter. So that depending on the band. Then site, location helps recognition, where it is located. So a sand body will be located along a large water body. So that is the site. Now texture, a dense forest, a conifer forest and a deciduous forest will have different textures. So we can identify. Similarly for agricultural lands or agricultural fields, different crops will have different textures, and based on that we can identify different features there. Same with the shadow associated with the different objects will help us to find out. And because the sharp shadow is there with corners and other things, seems to be a man-made objects rather than natural. Associations like bridge will be associated on the road, on either a crossing, maybe flyover, or on a river. So that is the association, and based on that we can identify. Maybe pattern of cities, block wise and so on and so forth. So it is very easy to identify. Now I am giving you some real examples here, like there is a water body, this is false color composite, and we can say that these might be the agricultural land or agricultural fields are here. Because there is a water body, hence there is a supply of water, and they are getting water, these farmers, and growing different crops here. So this is association and texture, color, tone, everything is being played while doing this kind of interpretations. Whereas other areas do not have much vegetations. So we may call them as bare. Also we involve different data sets, like if I involve a digital elevation model. Now I am having a height information. Here I do not have height information with the satellite image. But if I am having a digital elevation along with me, I can now say that this reservoir, though small, is located on higher grounds, because here it is having higher pixel values or cell values. And whereas the reservoir, this one, is located on lower ground because it is dark tone. So I am now having the height. Now I can make further interpretations that though this reservoir, and another one is this reservoir is in blue color, this reservoir in black color. That means though this is reservoir on higher grounds, but probably it might be having turbidity in it, or depth of or water column, the thickness of water column might be very less, and therefore the bottom is reflecting the light. And in false color composite, generally a freshwater body should appear completely black or dark, very dark, like this one. Whereas this one is appearing dark. So here one can argue that they might be polluted or might be completely clean, no turbidity, and therefore it is appearing dark. So now when we want to make sure 100% that what is really on the ground, then at that time it has to be checked on the ground. But after checking the ground, and if you are seeing the similar characteristics in similar other reservoirs, then one develops that interpretation skills and then can make better interpretations on images. And then comes the inferences. So one can identify, based on this understanding or knowledge, one can identify develop that interpretation to that stage where you start making inferences and some thinking about some future. So you know that if there is some areas which are having higher grounds and across like a quartz reef, and there is a river which is going across, and that area is having groundwater problem, then you know that if I block that create a dam using that quartz reef as dam axis and block that area, then I can create a reservoir, and that will recharge the groundwater regime. So this is coming directly through image interpretation, and likewise one can perform lot of image interpretations and later on inferences, and then think about the solutions of an area where might be having a problem of water or agriculture or some other things. So this brings to the end of image interpretation. Thank you very much.